All right, so we want to come up with the equations of these just, for, using later, those kind of things. This is a constant function, so it's just, a nice horizontal line, y equals -4. Don't get it confused with x equals. X equals are the vertical ones, so don't get it confused there. And then we go a little bit more complicated, right? This one has, looks like a slope of down 3 and over 2. So that's a -3/2x plus 5 is the y-intercept. Now, I have noticed kids don't realize that slopes that go down to the right have a negative slope, and anything that goes up to the right like that has a positive slope. That was something that came up in class today. People think that, something has a negative slope if it goes down to the left. And I'm like, no. You're looking at it the wrong direction there. Anything goes up to the right is positive slope. Anything goes down to the right is negative slope. Of course, this one is a parabola that's been flipped over the x-axis, so it definitely has a negative on the outside, which is a change on the y, right? We talked about how that reflects over the x-axis and causes it to go down. And then we have, it went to the right 2, so we would have x minus 2. Since it's a parabola, it would be squared. And then it went up 5, so the up 5 happens on the outside, right? Changes on the y or on the outside. This one being an absolute value function, it did go to the left 3. You can see it went left 3. It also went down 2, so that would be on the outside to make that happen. And we'll go to the next slide. So if I'm saying her name correctly, Alani has a summer job as a lifeguard. She makes $8 per hour for up to 40 hours per week. If she works more than 40 hours, then she makes 1.5 times her hourly pay. That means she gets $12 an hour. So she gets $4 extra an hour for the hours that are over 40. She does not get the extra $4 for all the hours she worked, just the part over 40 hours. Make a graph and write the function as this is to illustrate something that we call piecewise defined functions. In other words, the graph will change in the middle. It will not stay the same the whole way through the graph. It will change in the middle. So let's write some coordinates down here, and then we'll plot some points. So at 20 bucks or 20 hours and $8 an hour, that's $160. 25 times 8, that would be 200. Now you can see that it went up by 40 bucks. Each time she goes up another $5 an hour, it's going to go up $40 and another $40 and another $40. But something happens right at this point. Once she crosses the 40-hour mark, something changes, okay? Because she gets the 320, but then she gets $4 extra per hour for the remaining parts. Okay? So it's almost like it's a different function when we get to that point. So up to this point, all of this stuff, wow, that's a horrible looking brace. Let's try that again. All of this stuff has been y equals 8x. Okay? And that's for pay from 0 to 40 hours. But now when she hits the 45 mark, she's going to get $12 an hour. But something different's happening. Okay? You can't say $12 an hour for all 40 hours or all 45 hours. It's just the number of hours above 40. So that's why you have to throw in this x minus 40 thing. So what we're defining is called a piecewise function. So let's see here. If we plug in 45 into that, 320 plus 12 parenthesis 45 minus 40, we end up with 380. See, before it was going up by 40, but now it's going up by 60 bucks. And then I'm sure if it goes up another 60, you would go to 440. And if you go up another 60, you would get to $500. And so we can plot some points on our graph. Let's use bigger circles. So 20 gets me, oops, I better drag this over just a little bit. 20 gets me $1.60, and 25 gets me 200, and then 240, and then 280, and then 320. But then I'm going to choose a different color just so it makes sense. But then after that, 45 goes to 380. And then 440. And then 500. In other words, it changed. If we look at this, maybe draw lines, we can see that the slope of the line changed. It's not the same. So maybe I should redraw this a little bit. Maybe I should say y equals, and use a brace, and that would be from 40 hours, technically to infinity, but we know you don't have that many hours in a week. So let's see here. If you worked 24 hours a day for 7 days a week, you'd get to a 168. So we should change that to 168. Of course, you'd probably be dead because you've worked 7 days in a row without actually sleeping or eating or any of that good stuff. So, not a good thing. How much will Alani make if she works 37 hours? Well, 37 times 8, that's 37 times 8 is $296. Of course, that's before taxes, before the government decides to take a bunch of your money. So with the 43 hours, that's 320 bucks for the first 40 hours. And then she makes three of the hours are above 40, and she makes $12 an hour there. So 320 plus 36 makes 356. You might notice that I'm using interval notation. No, yes, interval notation instead of inequality notation. I'm a big fan of using interval notation, and I think that we should see both, but since we're really getting used to using interval notation, it really is going to be much easier for you if you use interval notation. All right, so we're going to be writing piecewise functions. So in this case, we're going to have 3 pieces. One for this part, one for this part, and one for that part. Now, I want you to notice, let's talk about the interval. Like for instance, this goes from negative infinity over here to -3. Okay, so when you write the interval that goes with the equation for that very first line, this one right here, over on the right side, I want you to put negative infinity to -3. Now, because that's an open circle, that's got to be a parenthesis. Okay, now the next one down, that goes from -3 over here to +1, and it's closed on the left and open on the right. And then the last piece on the far right goes from closed 1 to infinity. So first of all, write all that stuff down to begin with. Then come back here, and I'm just going to erase this so we can kind of get an idea of what's going on here. We'll focus our attention on this part right here. Okay, let me zoom in on it a little bit. If you were to take that line and you were to extend it out till it hit the y-axis, where would it hit the y-axis? Now, I know that's not the most exact way to do this. For now, it is a necessary evil that we use our kind of our knowledge of slopes. You know, we can say things like, oh, this is up 2 and over 3, and then you just continue that pattern and you can see where it hits the y-axis, okay? But, so obviously it's going to hit at -1. So we know the slope of that is going to be 2/3. So 2 up 2 to the right 3, and it has a y-intercept of -1. Now, keep in mind, this one right here, lots of kids want to look at this and say, oh, well, that's got a negative slope. And remember what I talked about at the beginning? If something goes up to the right, it has a positive slope. Okay? Just because the arrow goes down to the left does not mean that that line does not have a positive slope. So don't get that in your mind because that is a very common mistake. Okay? Now the next part, right there in the middle, is pretty easy. That's a constant. That's y equals 5. We got the y equals part over here, and so you just need to put a 5 on that line. And now for the last one over here. It looks like it has up 4 over 1, up 4 over 1. So that is a slope of 4. And if you were to carry that down, you would hit it at -8 for your y-intercept. So if you would just carry that line backwards, you would run into, oops, sorry, got to hit the erase tool. You would hit that at -8 down there at the bottom there. So that's the piecewise function from that picture. Okay, so we're going to try a couple more of these. So we've got y equals, and we're going to do 1, 2, 3. We can go from -infinity to -2, and from -2 to 4, and 4 to infinity. So let's see, -infinity to -2, and that's got to be a bracket because of the closed dot. And then from open -2 to 4 closed, because it's closed on the right there, and then open 4 to infinity. Now we can take a look at what else we have here. It appears that it comes down 3 and over 2. So that is a negative 3 halves x. And if I were to continue that, it looks like it would run into negative 6 on the y-axis. The next one looks like it goes up 1 and over 2. So that'd be a 1/2 x, and it clearly runs into the y-axis at negative 5. Lastly, the one on the far right is just plain old 6. Don't have to worry about anything because it's just a constant. And that's the equation, or the piecewise function for this particular graph. On this next one over, we've got only 2 things. And it looks like it goes from negative infinity to negative 2, and from negative 2 to infinity. So we have negative infinity to negative 2 open, but then closed from negative 2 to infinity. Now, the first one on the far left here, once again, positive slope. Looks like it goes up 1 over 2, up 1 over 2. And if you would continue that, it looks like it would run into negative 2. Now the next one's a parabola. And remember the kind of the shape of the equation of a parabola. Something squared. Since this thing went to the right one or left 1 unit, we needed to say left 1, and we also needed to say up 1. So left 1 would be x plus 1 on the inside. Up 1 would be a plus 1 on the outside. Remember how it goes against your common sense on the inside for x, but it matches your common sense on the outside for y. Let's go to the next slide. One, two, three. All right, so let's see here. We're cutting there at negative 5 and over here at 2. So let's see here. Negative infinity to negative 5 bracket, parenthesis, negative 5 to 2 parenthesis, and bracket 2 comma infinity parenthesis. Okay? The first one is a line, right? It looks like the slope is down 2 over 1. So that is a negative 2x. If you were to continue that pattern and just keep going down 2 over 1, down 2 over 1, down 2 over 1, looks like you would land at negative 5. The next one is an absolute value function. First of all, it's been flipped over well, let's see here. Let's do the absolute value bars. We know it went left 2. So on the inside, that'd be x plus 2. It also went up 6. So that'd be a plus 6 on the outside. But to get it to reflect over the x-axis, to flip upside down, you got to have that negative in front. The slopes of the lines are 1 and negative 1, so they didn't change the slopes. So we don't have to have a different negative number. Just having a negative 1 out in front like that works. Okay, and then let's see here. Last one here is just y equals negative 1, just a nice constant slope line. Okay, last part of these notes, you need to be able to find. So we have an x value on the inside, but they're asking me for a y value. So they want the y value when the x value is negative 6. So I have to come over to my graph, look at negative 6, find it on the x-axis, go up and find the coordinate on the correct graph, and see that the y value is 7. So that's the coordinate negative 6, 7. Next coordinate over here on the right is I go to negative 5. Remember, you got to go to the closed dot, not the open dot, the closed dot. So that is a 5. F of negative 2, that goes to the top there, which is a 6. F of 0, that goes to that dot right there, which is a 4. F of 2, always go to the closed dot. So 2 is the x value, negative 1 is the y value. And lastly, f of 5 is right there at negative 1. So those are the complete answers for that set of notes.